Boa tarde a todos, pessoal. Sejam todos bem-vindos aí a mais um seminário em iluminação. O nosso seminário de hoje vai ser com o professor George Zissis. Vai ser um seminário em inglês, não é? Então eu vou dar só alguns avisos aqui em português ainda, e depois a gente vai seguir com a apresentação em inglês. I have here Pascal and Leos in the audience. I just want to tell you that I will give only some information for the Brazilian students in Portuguese, but all the seminar will be in English. Thank you for your audience. Então, pessoal, só para dar alguns avisos importantes, não é? Para os interessados no certificado de participação do seminário, né, que vai estar sendo fornecido aí pelo ramo estudantil I3E da UFSM. A gente tem ali nas primeiras mensagens do chat um link para um formulário. É só preencher aquele formulário ali com os dados de vocês e vocês vão estar recebendo então o certificado, tá certo? Eu vou convidar agora o professor Guilherme Márcio, da Universidade Federal de Juiz de Fora, né? Lembrando que esses seminários estão sendo aí organizados conjuntamente entre a UFSM e Juiz de Fora, e também participação do pessoal da Universidade Federal do Ceará. Então, o professor Guilherme Márcio ele vai fazer aí a apresentação do professor George.
Hi, everyone. It's a pleasure to present Professor George Zissis, which is an important figure in the lighting scenario in the world. He was president of the IEEE Industrial Application Society and is currently the Vice-Rector of Toulouse University. Born in Athens in 1964, has graduated in 1980 from Physics Department of University of Crete in General Physics. He's got his Master and PhD in Plasma Science in 1987 and 1990 from Toulouse University, where he is currently a full professor. His primary area of work is in this field of light source science and technology, where he's especially interested in physics of electron discharges used as light source, since system and metrology issues and solid-state lighting. Professor George Zissis is also director of Light and Matter Research Group of LAPLACE that enrolls about 20 researchers. He won several international awards and is currently the chairman of the 4E Solid-State Lighting Annex of the International Energy Agency. Today, Professor George will present and speech is entitled Smart Human-Centric Lighting System Towards the Lighting 4.0 Era. Welcome, Professor George Zissis, and I expect that you have a great time with us.
Thank you very much, Guillermo. Thank you very much, Marco. I am really glad to be with you today and give me the opportunity to speak to your students about smart lighting or the next generation of light sources. I will share my screen. Just a moment, that one. It's okay, you can see my screen. Okay. As has been announced, I will explain you what is a brandly new concept named the Right Smart Lighting Challenge. And it's something that will drive us most probably in the next 5 to 10 years to the lighting 4.0 era. Well, let's start from the fundamental. Today, when you look around you, artificial light and artificial lighting is everywhere. Look, for example, a nice photo of my city here in France, Toulouse by night, and you will discover that there are various, I don't know if I can have my, yeah, let me see, take, yeah, the pointer. You can see here different usage of artificial lighting, like monument lighting, street lighting, indoor lighting inside our homes, signage, display, but also lighting for our cars, our trains, aircrafts, and so on. And beyond all this real illumination lighting application, we use today light sources for different applications, like photo treatment or growing plants for greenhouses, for cleaning air and water, and different other non-lighting applications. Of course, here today I will not speak about those non-lighting aspects. Once again, looking inside the city and taking only into account the illumination applications, you will discover that lighting cover multiple functions. The first and the most basic function of artificial lighting is being able to see around you, but also be seen from the others. And that in order to locate, be able to identify an object, a person, and this make you feel secure, or also contribute directly to be secure. Lighting allows you also to communicate. Try to speak to someone if you cannot see him, and you will see that you don't have any wish to discuss with a person that you cannot see. Light also allow us to appreciate the monuments, the city, but also enhance and make them more fancy. And also, the last but not the least, artificial lighting is used today to create ambience. Next slide I will give you some global figures in order to explain you what represent artificial lighting today. We estimate that worldwide, every day, something like more than 30 billion electric lamps operate in our planet to light up our lives, our cities, our homes. And these 30 billion lamps absorb 16.5% of the world electricity production, which is the equivalent of 2,900 terawatt hours. I remember you that a tera is a 10 to 12. We are speaking here something like in the order of 3 times 10 to 15 watt hours, which is just 2% of the world annual primary resources. We use that just to light up our lives. And of course, if we consume electricity, this electricity is produced somehow, and we are responsible for producing, for example, greenhouse gas. And 2,900 terawatt hours consumed worldwide for lighting correspond to 1.15 billion metric tons of CO2 injected every year in our atmosphere, which is 5% of the world CO2 annual emissions, or if you wish, is the equivalent of 230 million people global CO2 emissions. You understand here that is a very important impact to our environment. 40 to 45% of the 30 billion electric lamps today, they are powered by LEDs, by light emitting diodes. And in fact, 40 to 45%, this is not exactly the share of the number of lamps, but is the revenue of the market share. But it's very, it is proportional. It is very interesting to know that maybe 5 years ago, or maybe 3 years ago, this percentage was just 5%. That means in 5 to 3 years from now, this figure really increase exponentially, and the increase is still going up. Speaking about money now, lighting industry, that means light sources, drivers, luminaires, and associated stuff, everything except the lighting design, represent an annual turnover of 120 billion US dollars. And as you can see, this turnover, this world turnover is constantly increasing year to year, with a year-on-year rate in the order of 1% per year, which is really huge. And there is no any indication that this increase will collapse in the next years, even due to a pandemic situation. As you can understand now, this figure shows clearly that artificial lighting has a large impact on energy, environment, but also, as I explained you in the previous slide, has impact on everyday's life and also to the world economy. Let's show something more specific. I remember you the 2,900 terawatt hours of electricity consumed per year. Where is going this huge amount of energy? Almost half of that, 48%, is used to illuminate tertiary buildings. What are tertiary buildings? Are hospitals, universities, schools, stores, and things like that. One third of that, 28%, is used to light up our homes. 16% to light up big industrial plants, and 8% is used to illuminate our cities. I remember you that is 16.5% of the world electricity production, but now if you look country by country, the situation is a little bit different. For example, if you take France, 12% of French electricity used, not produced, used every year, is creating light, 9% for Germany. And in fact, all Western countries, Western economy type countries, they use between 7 and 15% of their electricity consumption every year to produce artificial light. With one exception, United States. United States, they are using today 21% of their electricity consumption to produce light. And this 21% of electricity used in the United States for lighting correspond to the full electricity production of France and Italy together. You can ask why United States, they are so singular point. There are several explanations. The first is that US has a larger surface to illuminate per capita, per user, if you want. You know, everything is bigger in US. The second point is that US is well behind any energy efficient lighting measures. For example, if you take California, they try to ban incandescent lamp. This is okay. But if you go to central US and deep US states, energy consuming lamps like incandescent lamp, they are still present. It's much more funny if you look what happened in developing or underdevelopment countries. You will discover, for example, that in Tunisia, 34% of their electricity consumption per year is used for lighting, 40% for Madagascar, and up to 86% for Tanzania, which is the champion in the domain. You understand here quickly that for developing countries, being able to control lighting consumption and use the right light at the right place and at the right moment, it is a real sustainable development target. And this is very, very important. Once again, I remember you the side effects of lighting: 1.15 billion tons of CO2 every year in our atmosphere, but also the majority of light sources beyond LEDs and incandescent lamps contain mercury. Mercury is a very toxic material, and if you go to a country like in France or in Europe, that we are in obligation to collect our lamps and recycle them, we collect in France every week 80 tons of mercury contaminated wastes that we need to retreat and neutralize before throw it in the environment. And of course, there is another very important point. I will not speak here extensively. That could be an idea for another talk, another day. When we produce artificial light to illuminate our buildings, our cities, our commercial centers, we create light pollution of the skies, and that has several side effects. For example, we are not able to see the stars, but this is not very dangerous. But some other effects, like influence of the biotope, attracting some species, insects, animals, or repulsing some others, completely modifies the biotope. And this is a very negative impact in our world, and of course in mid or long term in our own lives. Let's look. I spoke to you about lighting 4.0 area. Let's look the way forward to this fourth revolution in the domain of lighting. In fact, it is very funny. You will see here an idea of our the evolution of our species. The human being evolved since million years, and the most funny thing is that our species co-evolutes with lighting systems. It's something that we use from the beginning of the humanity. Well, oops, I need to do that. If you take an arrow indicating the time, of course, there are several 100,000 years or maybe million years that human being started using fire in order to illuminate. And we have proofs. I will not say historical proofs because we are in prehistory, but we have proofs in prehistoric sites that at least 30 to 35,000 years from our modern era, human being dissociate the illuminating behavior of the fire from any other function. That means heating, cooking, and things like that. That was the first revolution in the domain of lighting. The second revolution came several thousand years later. We are speaking here end of 19th century, when for the first time electricity was used to create artificial lighting. This is the lighting 2.0 era, starting at around 1840, which is almost 200 years from today, back today. Well, it is very funny to see now what happened. This is the starting point for us, the electrical lighting. When electrical lighting arrives at the end of 19th century or beginning of 20th century, the only need of humans was to light up, being able to switch on and off the light when you want and as you want. That was the only request for the lighting systems, and this is very limiting, because if you have only just to switch on and off the light, you can of course play a little bit with the technology in order to enhance the products, but always you are limited because you are looking only one component of the full system. Let's continue now a little bit ahead in this time scale. And when you arrive in the period between the two worlds, the first and the second world, you will discover that scientists work more and more in the domain of sensing. We start creating different type of sensors, sensors of temperature, sensor of position, sensor of speed, of what you want. This is completely disconnected from lighting, at least at that time. And then you arrive somewhere here, which is early 70s, 1970s, with the arrival of the first oil crisis. And at that moment, our governments, our politicians, they discover that lighting use a lot of energy, and also much of that energy is just spilled. Well, they submit the idea to go forward and create that they call at that moment the energy efficient lighting, which going together with the rational use of energy. And this gave a very nice idea. What about if we connect sensors and lighting technology? And we create that way the first innovation in the domain, which is having lighting and a sensor. And when you are present in your office, the light is switched on. When you go out, the light is switched off. This is the principle. In reality, the system was not working so nice, but it was a first step. Let's continue a little bit further. End of 20th century, 1919, something like that. LEDs, light emitting diodes, white light emitting diodes arrive. And this opened the era of LEDification of lighting. LEDs, they are electronic components, and as such electronic components, they are very flexible. We can control, we can change the intensity, we can change the color, we can change the color temperature, we can do many things with LED systems. And at that moment, lighting industry had a new idea, was try to combine human factors. That means take into account human needs for the right quality, not only quantity of light, and they create that we call the human-centric lighting concept. From the other side, information and communication technology advance allow to interconnect sensor networks and lighting networks in order to create connected lighting systems. We are just here today. In 2020, we're somewhere here. What will be the next step? The next step will be to make interacting human-centric lighting and connected lighting interacting with the end user, the human being. And this is the situation today. We are at the situation 3.5, if you want. And if you make interacting human-centric and connected lighting, you can get, then that will be the next step, the smart lighting system. And we expect this smart lighting system will be, in fact, that we will have in a few years from now, and that will be the fourth revolution in the domain of lighting. Why? Because this smart lighting can be the basis for smart buildings, because we have a very dense mesh inside the buildings. Look around you, you have a lamp at least in a 1 to 2 meters distance from you, and you have a very dense network. And of course, Smart buildings, they are the basis of smart cities. They need smart grids in order to be supplied. And now if you make interacting smart lighting systems, the lamps and things like that, with other connected objects, you enter the domain of the Internet of Things. And here you go to the next generation of lighting, which is the digital lighting. We enter the digitalization period of lighting. And here, many things will change. First of all, up to now, when you wanted to buy something about lighting, you buy bulbs, you buy luminaires, fixtures, or drivers, and you illuminate. Most probably, in the next 1 or 2 decades from now, the system will become so complex and so expensive initially, and all the lighting industry economical model will change. The light will become a service. That means instead to buy a lamp, most probably you will invest to a complex lighting system, and you will pay for the light that the system produces. On the other hand, as the system is intelligent and is communicating, can collect information, can transmit information also through visual light communications or Wi-Fi. And then, as you can imagine, your data, our data, will become a product for the people that they sell us the light as a service. And then, of course, we enter another problematics, another subject, which is what we can accept, what is acceptable about privacy, about everyday's life, and what is not acceptable. And this is something very, very complex to treat immediately, and of course is not part of what engineers or physicists or electrical engineers will have to treat. Okay, I spoke to you about smart lighting, but the first thing is, what is a smart lighting system? To be honest, I look in internet, I look around me, I could not find a definition of what is smart lighting system. Well, I decided to produce my own definition that you can see here. A smart lighting system has a principal function, which is to produce at any moment the right light. That means where it is needed and when it is necessary. It should adapt the quantity and quality of light to enhance visual performance in agreement with the type of executed task. You need to know what you are doing. For example, I'm doing a presentation to you. I'm looking my screen, and my lighting system has to find what I'm doing now and adapt the light that I need for that task. Then it must guarantee the well-being, health, and safety of the end users. This is fundamental. It should not squander passively the resources of our planet, energy, for example, and limit actively all the effects of light pollution on the biotope or any other impacts on our environment. And finally, in the definition that I gave, I add the final sentence, which is ideally a smart lighting system could offer additional service, for example, geolocalization, data connectivity to the end users through visual light communication protocols. And now, if you take that definition and you decline to smart lighting functions, what is offered by your system? One function is to adapt dynamically the light quantity and light distribution in space, but also the light quality in terms of color temperature, of color rendering index or spectrum, and optimize that way the visual performance, and of course respect any normative and security requirements. The second important function of a smart lighting systems is to avoid any visual disturbances like glare, light flicker, stroboscopic effects, shadows that can compromise end users' security and well-being at any moment. The third function is always reduce energy consumption. This is an obligation of the installation without compromising the above conditions. The fourth one is actively limit the effect of light pollution on the ecosystem and biotope, respecting the new sky protection legislation and standards that more and more countries are adopting now. And if necessary, as I told, relay information via VLC. An example is giving a reference for geolocalization, or give you the possibility to connect your smartphone or your computer and getting data passing through Wi-Fi. Let's look closer at the two components of the smart lighting system, and let's starting by the human-centric lighting. It's something maybe you hear somewhere. What is the human-centric lighting? In fact, it's a system that mimics the daylight, and especially the daylight variations. For example, we know when the sun is at zenith, that means in noon, we have a lot of light. We have a high color temperature. We are speaking about color temperatures in the order of 5,000 to 6,000 Kelvin, and we have a very uniform light. The light is coming vertically, that means very low shadows. On the opposite, if you take the sunset, you have less light. The color temperature is lower. We are in a color temperature of around 3,000, 3,500 Kelvin. And as the light is coming with a different incidence angle, you have shadows. That means you have less uniformity. And we know since the end of 20th century, when we discover some additional photoreceptor in our eyes, we know that this variation of color quality during the daytime has a very important impact in our organism, because it regulates the quantity of two different hormones, the melatonin, which is the hormone that pushes you to go to sleep, and the cortisol, which is the hormone that wakes you up. That means the variation of light, natural light, is something that influences our daily circadian rhythm and allow us to adjust our circadian clocks that are based in our brain. And this has very important applications. Well, when we speak about human-centric lighting, which is the next step in the domain of lighting, we are fully on that today. That means we need a biologically effective lighting, representing lighting systems that are appropriate to stimulate biological organism and improving our cognitive performances. Also, we can use this light variation and these human-centric lighting systems to create emotionally effective lighting systems designed to create emotionally stimulating environments and appealing atmospheres. And of course, a first and immediate application to that is use this human-centric lighting concept in order to enhance the quality of life of elder people or disabled people. For example, smart lighting can provide the best lighting condition for elders in order to avoid accidents, or even for visually impaired persons in order to facilitate everyday tasks. This is something that we need to more and more to implement and take into account in our modern lighting systems. You see, we are no more in the situation of the beginning of 20th century, when the only need was just switch on and off the light. We go well beyond that. Let's see what happened inside a city. For example, connected lighting in a smart city, for example, lighting can use different technologies of sensors. Could be position sensors, could be cameras, or I don't know what other. And you see, for example, when this person passes nearby the lighting poles, it is detected. We know which is his direction, what is his speed, and then we can switch on and off the lighting in order to follow him and allow him to feel in security. Okay. On the other hand, now look this figure here. You see that in a city you have lighting poles, and in many cases the distance between those lighting poles is something like between 10 and 30 meters. And that means you can create a mesh inside the city, and your lighting poles can communicate between them, of course, relay information from one pole to another, but they can also transmit information to your mobile phones, or transmit information to smart cars passing through, for example, Wi-Fi, or even better, through Li-Fi. And of course, when you have this connected smart lighting, you can reduce vulnerabilities. What means that? You can identify, for example, in a city, a vulnerable situation. Could be a person, could be a car, I don't know what. And once you identify this vulnerable situation, you can broadcast the others, telling, be careful. This is a very nice example. A guy who going up after a nice fiesta, and he's zigzagging in the pedestrian area. This guy has a smartphone. His smartphone can be located by the lighting poles. The lighting poles can understand that he has not a straight trajectory, but is zigzagging, which is not very normal. And this person is very vulnerable, because if for one reason or for another decide to go to the road and the street, and then you have a car arriving at 50 kilometers an hour, you understand why he is vulnerable. And if the lighting system can identify this guy in the city, the first thing that the lighting system can send is a broadcasting information to all cars entering in that section. Be careful, you have a UFO that can arrive at any time in the street. And of course, this is again a privacy information. You can broadcast that information to police department and send someone to collect the guy. This may be acceptable in China. It could be much more difficult to make it acceptable in our countries. What about additional service? Always in the domain of the cities, for example, if you take communicating lighting systems, for example, you can transmit information to the cars. For example, you can say to that red car that what is the status of the three color lighting system, or that you enter the city limits and you have to limit your speed, or explain you if there is traffic jams, show you your destination and all that stuff. Or even, for example, the lighting system equipped with cameras. This is an idea coming from a small French company, Cavantech. They can, for example, identify that you have an empty parking space here, and you can broadcast that information to the cars that they are roaming around this area looking for a parking spot. You have to know that today roaming for searching parking spots in the cities is responsible maybe for 20 to 25% of the additional gasoline or oil consumption from your cars. That means you can offer a service in your mobile phone. You can know exactly where they are available space to park. Connected lighting systems can do many other things. For example, they can communicate with other connected objects. For example, the lighting poles in the city can communicate, of course, with the car, the pedestrians, but they can communicate also with the buildings and the connected system inside the buildings. For example, they can collect information about energy, electricity consumption, or water consumption of your buildings, broadcast that information to electricity companies for billing, and so on. Of course, when you take that holistic view of the modern lighting systems, you understand that today we are speaking about a lighting system which is almost independent, but this lighting system will be a sub-function somehow in a complex information communication technology system. It will be a subsystem inside the Internet of Things global system. And light in that case will be the vector of new services, as I will explain you, and can be also the carrier of data flows. And just to give you an idea, according some market research, Li-Fi and in general visual lighting communications can grow to a huge amount of money. You see that we expect to have more than 115 billion US dollars by 2022, which is fully comparable to the full turnover of the actual lighting industry. What is the ideal configuration? This is the ideal configuration of a smart lighting system. Well, of course, you have the light source with capacity to change intensity, color, temperature, spectrum, even the distribution of the lighting beam and things like that. A part of this light is used to the task illumination. You see, for example, they are, for example, illuminating the city. There is a part that we need to avoid, that is responsible for the light pollution. And then look what happened now behind this just light source. Of course, you have the driver. The driver can communicate with different type of sensors. The sensors can, of course, they need power, but a different type of sensors, they can feed this multiplexer, and this can send information to driver. The driver can communicate from your side with wireless connections with, for example, a central control station or a data center. And behind that, you have the power feed from the mains that could be, of course, 230, 240 volt AC as we are using today. But most probably in the next few years, especially in smart buildings, this power network can switch to a low voltage DC network with a backbone of 400 volts, and then a distribution inside the different spaces at a much lower DC voltage. And of course, to feed the drivers, you need to have a microgrid controller that can communicate and manage energy coming from renewables, or of course store energy and send the energy to the mains or not. It depends. you have different configuration. This is the ideal configuration of a real smart lighting system. And I remember you, this system will be a subsystem of the Internet of Things global system. Well, what I'm telling here is not science fiction. It's something that today we have all the necessary technology in order to make assembly of those technologies and create these smart lighting systems. Look in this famous hype cycle who shows the phases in the technology development, any technology development, and you see here the different components and their maturity levels. For example, if you take sensors, they are absolutely mature. Maybe we have new concepts, but globally the sensors, they are mature. Information and communication technology is very close also to the maturity plateau, and the same thing for LED technology. If you take organic LEDs, which is also a very interesting technology for lighting, we are somewhere just out of that we call the death valley, and this product will become mature maybe in 1 decade from here. Look now what is coming up to maturity. Connected lighting is around here. We are at the moment that we are many people started to adopt that beyond the early adopters. And for Internet of Things technology is also in the phase that you have early adopters using it. You can find products in the market. Human-centric lighting is also at the same phase. Smart lighting is a little bit behind. Li-Fi, visual light communications, they are in the domain that we can find today the first generation of products in the market, but are relatively high price. And behind that, beyond that, you have new technologies arriving like laser lighting, which is in the early development stage. But when you look here, the different components that you need inside the smart lighting technology, you can be convinced that today we have all the components available. The question is how we can enhance them for those one in order to lower the price, and how we can combine, assemble them in order to create a real smart lighting system that fulfills all the functions that I showed you in the previous slides. And here comes the ultimate solution, the right human-centric smart lighting concept. Just I wanted to remind all of you, when you are working with lighting is used mainly to illuminate, and I wanted to insist on that. Illuminate doesn't mean flood objects, people, or buildings with light. If you do that, you will obtain very negative results. But that you need is to light up smart where it is needed and when it is necessary, and as best as possible. Well, how you can do that? In fact, you have to use the technology, all the technology of all the components that I showed you before that, take into account human and social needs, evaluate the impacts of the new technology, and enhance the technology and restart till fully optimizing the system. And today I can say that smart lighting development contributes to several world's grand challenges, like energy savings, contribute to healthy working environments and high task performance, contribute to silver economy. I spoke to you about elder people, contribute to lighting and IT technology and industry rise. Well, to achieve those objectives, a very cross-discipline efforts is required. In fact, to define what you need is, first of all, you need to define the target. The target is that we need an innovative lighting system. This innovative light system should be energy effective. We cannot negotiate that. Should be environmental friendly. This is exactly the same thing, sustainable development. But this should be also user friendly, easy to control, easy to appropriate, and must provide high performance and quality of life. In order to achieve all that, you need a high quality research at any level in universities, in research centers, also in industry. And when you make new research, sometimes you discover new things, and it happens that those new things, they are not measurable because there are no standards and metrology methods existing. Then you need to develop new standards and metrology. Of course, then you need to make technological development by taking the original research idea and transforming in a product. This is the R, and this is the D of the famous R&D. You need extra legislation. Why? Because something new can be forbidden by law because no one knows about it. What happened if now you can find something new, but it is forbidden? You have to change the legislation. You need training of high-level scientists, of industry engineers, but also training of resellers. Try to ask some information about a new technology lamp in a supermarket, and you will see what is the training level of the resellers if you find someone. You need also to train the policymakers, but also train the end users, the consumers, because the new systems, they are much more complex than just switch on and off the light. And of course, as the new system of that type, they are very expensive. You need to invent new inciting measures in order to reduce at the beginning artificially the price and make the system affordable for the different economies. To do that, you need also social knowledge. You need what is acceptable. And I spoke you in many times about privacy issues with the new technologies. And of course, you need to have a very good market knowledge. That means being able to fix a price of the new system that is affordable and acceptable by different economies in developed and rich countries, but also in underdeveloped and poor countries. Because for them, it is, as I explained you from the beginning, a real sustainable development issue. Okay, that was my last slide. Thank you very much for your attention. If you have questions, I'm open to discuss with you. And just put a small publicity about an important conference that I crossed the figures will happen face to face in November in my university in Toulouse, and our host Marco Della Costa is also a member of the International Scientific Committee of that conference. Well, thank you very much. I don't know how many time it took to present that. And it is time for questions.
Well, thank you very much, George, for your nice presentation.
I stop sharing my screen. If necessary, I will share again.
Okay. Now we will receive questions through the chat. So I ask for the audience to send your question through there. And but while we don't receive any question, Professor Guilherme wants to make some questions to you, George.
Okay. Of course. And congratulations for your nice presentation. It's a rich material for engineering site. We can see a lot of new trends, and I agree with you that there is a slide that you show that lighting systems like a sub module is not the main module in this new 4.0 era, and this is interesting. And my question, I would like to know your opinion about the research in lighting area, because in the past we were focused on the lighting technologies like discharge lamps, the LEDs, and now we have to come a lot of new, we have to understand a lot of new technologies like for example, VLC and communication technologies, and power electronics and other studies are not like the main areas nowadays in this kind of research. I would like to know if you think that the researchers in this area must evolve and become more multidisciplinary, like to understand IoT and other things? Or do you think that research in lighting technologies and drivers also will be important?
Well, yes, very good question. And as I explained you, all the domain of lighting is completely evolving and changing since few years now. Of course, always we will need some people working on the components. The component could be the LED or the organic LED or the laser diode, I don't know what other, or the driver or the optics. But this will be a more and more shrinking domain because all those products will become commercially available, will be mature. Look, for example, today, to be honest, in legacy technologies like fluorescent lamps, HID lamps, and all that stuff, there are many interesting scientific questions to treat and solve, but no one is doing any more real research because you cannot have any funding on that. Try just to submit a project speaking about discharge lamps, and you can be absolutely sure that you will get 0 cents at any currency. Well, it's something that can happen also if you stay only on the driver, even if you open the driver to communication and all that stuff. I think laboratories like ours working on illumination, on lighting, we start to have a broad approach of the system. We needed to have this holistic approach of the system. Of course, we cannot do everything, all of us. I am specialist of lighting. Friday, I will show you what we are doing in my team. But if you want, since a few years now, I'm opening more and more in the domains, going to the environmental impact, going to the impact on the ecosystem, also the different sociological aspects. And of course, I cannot treat myself, but in that case, I try to find a specialist in social science, in telecommunications, in the computer science that I can discuss. And the idea is to extend more and more the knowledge. And what is valuable today for our labs is to collect that knowledge and have a huge knowledge, because industry today has other objectives. Lighting industry invests much money for research. Why? Because it was a almost oligopoly or monopoly situation. And when you have monopolistic situation, then you can invest money for research. Today, looking the number of new companies of all the industrial ecosystem in the domain of smart lighting. The domain is so competitive that industry cannot invest a lot of money for research. And if you, me, Marcos Alonso, and things like that, people working on lighting, we aggregate and we cluster different aspects of the full system. We have the database, and they will come to us because they need our knowledge. Okay? Up to now, they came to us because they have money to spend. Now the situation can change. Their economic model will change, but our economic model also have to change. And we have to say, hey, look, we have all that you lost since several years now, and we can help you really to create a nice system. Otherwise, they have very good ideas. Look how many small companies they develop futuristic ideas, and when they really set up the idea and you have a demonstration in a city in a don't know what, maybe a couple of months or couple of years later, the city will completely change because it's absolutely amazing. It's not working. It's not well. Yeah, because those people, they don't know what is the reality of illumination. That is my position. We have to go more and more in this cross-discipline aspect. And cross-discipline starts from electrical engineering and goes up to arts, if you want. Arts, design, all that you have to take into account.
Thank you. I agree. I totally agree with you. I think that this cross area is very important because it's very difficult for us. We don't have, I can see, we don't have from any research in IoT and not other areas. And now we have to aggregate other universities and colleagues and other researchers from these areas to evolve. I agree.
There are two options. Again, the option one, which is that I told and you are speaking also, is become a sub team in another team on IoTs. Okay, and then you lost your independence, your way of thinking and things like that. This is one point. This is the easiest maybe option, provide that you have someone around you that is dealing with such aspects. The second option, and this is my vision, is we can aggregate our forces in international level. We are speaking more and more about mondialization. Just apply that mondialization to all of us and create something visible worldwide that is has the fundamental knowledge, and then we will say to our colleagues, you see, we need that, come to us, not the opposite. If we do the opposite, we will lose our souls.
Yes. It's like a knowledge cluster that we must create.
That I am trying to create by creating a smart lighting initiative inside IEEE. I'm crossing the figures that I will have positive answer, and if I get some seed funding for that, I think we have to explore that way in order to cluster our stuff and create, I don't know, an international smart lighting initiative, and say we are the experts in that domain, and in order to provide more services to the industry, we need additional knowledge. Please come to us.
Right. Marco, can you I think that we have questions.
Yes, George, we have a question here from Pascal. So, well, we have a very nice attendance here in your presentation. But Pascal is asking about He says that one of the new trending is low-tech approach, build device with low energy consumption that are easy to repair. Do you think such approach can be used with the smart lighting systems?
Yeah, of course. Thanks, Pascal, for the question. It is true that you never asked me that question face to face. But yes, you are right. Today, we have two approaches. We have the low-cost approach. You are speaking about that. And then you have the high-quality approach. The problem is when you look really what is a real smart lighting system with all the functionalities that I will explain before, you can understand that the low-cost option is not working. And this is the main problem. That's because you take every day, most probably in that world, you have several new small enterprises creation on lighting. They propose system low cost because they said, yeah, you don't have to put, I don't know how many $100 for a lighting pole for the city, or maybe $10 for a lamp, something like that. They propose low cost solution, but the low cost in the domain of lighting is equivalent of low quality of the product. And no one like low quality product. If you want really to create something coherent and sustainable, you need to go to high quality and of course expensive systems. That's because I told you that the logic will change completely. Look what happened with cars. Now, if you take a car from 70s, you have a problem. You go to any garage, they open the engine and they can make the repair, okay? And that car cost a lot of money some times ago. But if you come today, you have a very high quality, very expensive cars. And when you open the engine, you look the engine and you close again, and you have to go to something specialist. But what happened today? More and more car industry propose, instead of to buy your car, to rent the car for a given period of time. And in that case, inside the rental, you pay for all the repairs and all the system that is guaranteed by the industry. That will happen also, I think, for high quality, expensive lighting systems. Most probably you will invest a seed money, which is not the real value of the system. The system will not belong to you, will belong to the guy who made the installation. The guy will sell you the light, but will assure the maintenance of the system. And then the big question is, what happens with the data that the system will collect from you? And who belongs the data? You see? I think that the low-cost approach, even for poor countries and underdeveloped countries, is not the right approach. But I'm not economist. I'm not commercial person. This is my feeling, and I don't have a crystal ball to read the future.
Thank you, George. Before the next question, I just want to say to the audience that on this Friday we will have another presentation with Professor George that will present the topics of research of his lab. So everyone is invited to join us on this Friday at the same time. Well, now I think that Guilherme has another question to you, George.
Yeah.
Yes, it's regarding the economic attractiveness of the proposal of when we have a street lighting pole, for example, being like a service place. And we, for example, here in Brazil, the municipalities are responsible for providing the lighting service. But we have a lot of other services, such as surveillance, etc. How these stakeholders can plan together these actions? Because nowadays, these actions are not coordinated. I think, I don't know if in France or you know any initiative that deal with this issue.
Yes, well, I agree that the situation could be completely different from one country to another. Here also in France, the lighting system is belonging to the cities, and then there are different options how the lighting system is managed. But today, the cities or the subcontractors of the cities, because in some case they subcontract the use of the system, needs to provide those additional services, because the cities, they are asking for a very interesting additional service today is to equip, for example, lighting poles with plugs for the electrical cars. Okay, this is a service. Because you have poles every 10 to 20 meters, and this is a very nice place to put the electrical plug, because the power is arriving there. But also cities today, they want to reduce, for example, roaming time for parking, being able to locate parking places and broadcast to the people. And of course, you need to have cars that are able to receive that, or have the smartphones in order to get the information. This is something that the cities want to do. And what happened in many cases, if you have a subcontractor which is managing the lighting system for the city, this subcontractor in many cases manages also the parkings. And for him, it's important to attract people to his parkings in order to pay the parking fare. Cities, for example, they are very interested today to identify an accident nearby a lighting pole. If you have a camera, you can see that there is an accident around, and then you can broadcast in the police. I have seen an example in United States. There is a company, which is not a small company. I'm speaking about General Electric. They are commercializing today a system that can detect use of firearms inside the cities. In fact, it detects the noise of when you use a firearm, and then it broadcasts the information to the police. When you say that to a mayor, the mayor is delighted. Said, I want that. This is important, because it's important for the security of my citizens. And of course, it is important for the citizens. And if the citizens, they are happy, the mayor will be re-elected. And this is a very important force to push the technology.
Thank you.
George, we have two questions here in the chat. The first one is from Igor from the Federal University of Santa Maria. He asks if could you predict when more products focus on human-centric lighting would be widely available for emerging countries such as Brazil, for example?
I will say they are available today for any country. I don't remember the statistics. I have some statistics for Brazil about the number of smart homes, and of course also smart initiative in the cities, which are not neglectable. The problem is that all these type of systems, even for developed countries, they are very expensive, because we are at the beginning of the technological maturity of the product, and we have to contribute by buying those products to all the research and development efforts that they are sometimes several billions. Okay, but most probably more that products will become available to all of us the price will decrease. And I'm sure that in Brazil you can find human-centric lighting products. The question is, what is the quality? Who is selling that? What is the real idea? For example, if you go to buy a lamp that started to illuminate more and more when you wake up in the morning, they tell you that is human-centric intelligent lighting. Well, okay, this is stupid commercial lighting system, but I don't know. Maybe once again, I don't like to make predictions, but looking at the figures, maybe in the next decade, that means inside 2030s, this type of products will be much more affordable worldwide.
Okay, thank you.
Look what happened with the cars. Most probably Brazil changed the cars to more modern cars a little bit later than other countries, but most probably today this is no more the case. You have the same percentage, and in any case today, if you like to buy a car, an old-fashioned car, it's not possible. It will happen the same thing with the lamps. If you cannot find any more old-fashioned lamps, you will buy the new one.
Okay, George. Now I will read the last question. Is from Igor again, and he's asking, what are the main skills that lighting professionals must have to design products and develop new technologies?
Yeah, this is very nice question, and this is funny because Friday, when I present my team activities, I will speak about a European project that is running today in collaboration with other universities in Greece, for example, in Spain. And the idea is to create a new curricula for lighting engineers. I think today the most important quality that you have to have open spirit, being able to accept new ideas from non-scientific, not hard science domains, being able to understand those concepts, have green, of course, for the ecology ideas, and also, of course, have some ideas about sociology, about human perception, visual perception, how it works, not only how it works your eyes, but how the light quantity, the light quality, the light distribution can be used in order to enhance visual performance. The problem is yet start to define the visual performance. And the final question is you have to define also new performance metrics, because the new system, as I told you, we know measure lumen per watt, we know measure, I don't know, color under index, but those new metrics, they are not relevant for the new systems, and you have to train all the new lighting engineers to those new concepts, new metrics, and new needs. Globally, you need not only power electronics or illuminating engineering, but you need all of that together, with some economy, with some sociology, with some physiology, and also some psychology.
Well, thank you very much, George. And to thank you, I will put some messages here from our chat that are sent to you. So we have a very nice message about congratulations to your speech. Oh, we have Viviane.
Thank you, all of you.
Very friends from.
Yeah, from my
Europe,
friends. Yeah, from I forgot to say that this project is also well, this talk is also supported by a European project that we are running with Ales Richter from Czech Republic. When you see my slides, you have the R2P2 logo everywhere in the slides, and I would like to thanks for that, Ales. Okay, thank you.
Well, thank you very much, George. And see you on Friday for the next
Okay, thank you, thank you very much, and see you next Friday. Bye bye. Finally, how many people they are connected, Marco?
We had 47.
Wow, nice. Okay, okay. Bye bye, all of you. Nice afternoon for people in Brazil. Nice evening for people in Europe. And see you Friday for the next talk. Bye bye. I really enjoyed.
Bye bye. Thank you, Professor George.